Hi everybody, this is Mrs. Blasky. This is going to be our first video. I'll give you a little bit of background about how this is going to work out and how we're going to use these videos to help allow us to have a little bit more class time to work on all of the tricky things that we need to figure out in AP Chemistry. So here on my screen, you can see our calendar. This will be provided to you on Schoology. It will have links to all of the things that we are doing, including handouts, these videos, anything else that we do in class will all be linked here. There also will be access on Schoology. So these videos we are going to use, I'm going to try and keep them short. We're going to use them as your time at home to help prepare for class. You can use the notes packets while we're going through these videos. Those will all be available to you. To help sort of, instead of having to read a textbook, this is what we're going to do. You watch the video, you take some notes, you ask some questions, you bring those questions with you to class, and we will practice that material in class. Now, this first unit, Unit 0, should all be review from your first year chemistry class. So we're going to go through these pretty quickly, review it a little bit in class while we're going through. But as we get into more and more new material, these videos will become more and more important. I don't mind if you watch them on double speed, whatever you need to do to get through them, that's fine. Right now, these videos will be available on YouTube, so you should be able to access them on any device that you've got. Later on, we might change the program where these videos are available, but we'll talk about that in class. So if you've got your Unit 0 packet in front of you, we're going to go through the first two topics. We're going to do topic 0.1 and 0.2. Topic 0.1 talks about sig figs, which I know is everybody's favorite topic in the world. So in AP Chemistry, sig figs don't have kind of the same importance as they did in first year chemistry. We still need to pay attention to them, but it's much more important that we understand why those sig figs exist. Because sig figs really happen, and we have to concern ourselves with them because of the precision of the equipment that we have available to measure. So if you look at your packet, we've got a picture of a graduated cylinder. If we zoom in on that liquid level, we know that when we read liquid volumes, we're always supposed to read from the lowest part of the meniscus, that curve in the liquid. So as the arrow points, we want to make that reading right there. That meniscus right now is somewhere between 21 milliliters and 22 milliliters. I would hope that by now you would know that if you reported that as 21 milliliters, that would be wrong. That is underestimating that measurement much too much. If you reported that measurement as 22 milliliters, that also is incorrect. That is overestimating that measurement too much. So we know it's somewhere in the middle. What I want you to do, I want you to take a quick estimate, just without reading any of this, without doing anything, and I want you to write down what you think that reading should be right here in your packet. Interesting thing about this is you could ask several different people and you could get several different values. Because that measurement is somewhere between 21 and 22 milliliters, and those markings are every 1 milliliter, we are allowed to make a 1 decimal place estimate past the markings. So in this case, since our markings are every 1 milliliter, we are allowed to make an estimate to the tenths place, to 1 decimal place past that measurement. So your reading should be 21.4 milliliters, 21.5 milliliters, 21.6 milliliters, somewhere in that range. If you said 21.44 milliliters, we cannot do that. That is too many digits past the precision of our equipment. So thinking about that, if we look at example number 2, let's think of which of these are possible or unacceptable answers. So because we know that measurement needs to be somewhere between 21 and 22, anything that says 20 is out. That's got to be close. All right. Now, notice that this one has 2 decimal points, as does this one. That is not possible. Okay. If we had a different graduated cylinder that had markings every 10th of a milliliter, then that 2 decimal points to the 10th hundredths place would be a possible measurement. So we really need to pay more attention to the accuracy and the precision of our equipment. Right? As we go through these videos, I might not hit everything in here. I know that you guys can read, so make sure that you're also reading through everything in here. Now, all of this equipment might not be things that we deal with every day in the lab, but there's a sort of a ranking of accuracy, not accuracy, precision of our equipment that we have in the lab. Beakers are not very precise at all. They might have lines every 10, 20, 50 milliliters, depending on how large the beaker is. Means the most accurately we can read that to is probably to the 10th place. Possibly even larger than that on a beaker. Beakers are really good for holding liquids. They're not really good for measuring liquids. Graduated cylinders are what we use the most. Depending on their markings, we can read them to the nearest 10th or the nearest milliliter. If we need to be more accurate than that, we have these things called graduated pipettes. If we've used a burette also, where it's got the little knob on the bottom and you drip the liquid in, that also usually has those same graduated lines. And then something that I know we used in pre-AP while we were making solutions, but we probably don't have a whole lot of experience with these, are volumetric flasks or volumetric pipettes. These are the most accurate equipment that you will probably use in a high school chem lab, and they measure to the nearest thousandths place. Now, when we're doing math with these measurements, we need to pay attention to all the sig fig rules. Basically what this says is that if you write down a number that's not a 0, guaranteed it's going to be significant. Zeros are really the only place that things get wonky. Zeros that are sandwiched or between 2 non-zero numbers are significant. Leading zeros are not significant. So if it says 0.000, none of those leading zeros are significant. Trailing zeros to the right of the decimal are significant. I tend to refer to this rule as saying, why would you write 92.00 if those 2 zeros weren't important to your measurement? If it's just 92, just write 92. All right. The difference between zeros at the end of a big number, if it has a decimal point at the end, then count that 0 as significant. If there is no decimal point at the end, then count that 0 as not significant. Something else that we might not have discussed a whole lot is in scientific notation. If you have a number such as 5.02 times 10 to the 4th, we only look at the number at the beginning for its sig figs. The times 10 and whatever that exponent is has no influence on those sig figs. Doing math with these, you were supposed to practice this for your summer homework. If you are multiplying or dividing, you keep the least number of sig figs from what the numbers that you multiplied or divided. So 12.94 has 4 significant figures. 0.003 has only 1 significant figure. Those leading zeros are not significant. Only that 3 value is. So you go ahead and do all your math. You get your non-rounded answer. You look at that answer, and then you say, well, I need to round this to have only 1 significant figure. The leading zeros do not count. That 3 would be the first one. We look at the number after it. It's an 8. That tells us that that 3 needs to round up to a 4. Right? If you are adding and subtracting, you only look after the decimal. This is not based on sig figs. This is based on positions past the decimal. So in this case, we've got a number that's measured to the hundredths and a number that's measured to the thousandths, and we are adding them together. So again, we go ahead and add them together. We do not round yet. When we're all done with our calculation, we look and we say, well, 1 goes to the hundredths, 1 goes to the thousandths. Hundredths is the least precise, so I need to have my final answer round to the hundredths. We don't need to round that up. We're dropping off a 3. 3s do not make other numbers round up. Okay. Here are some example problems to help you practice this. The answers to these will be posted on Schoology so that you can check your work. If you've got questions about any of these, feel free to ask in class, send me a message, whatever you need to do. Right. And then real quick, topic 0.2, Avogadro's number, moles and molar mass. This is something that we do all the time. Just wanted to remind everybody that it's there and you need to be able to know how to use it. Avogadro's number, 6.022 times 10 to the 23. That number tells us how many particles are in a mole. A mole is a chemical value, like a dozen. It's just a counting number. We use that number to help us keep track of tiny things like atoms and molecules and particles because they are so small. Talking about single atoms is sort of not useful to us. So this mole value becomes much more useful to us. This number, 6.022 times 10 to the 23rd, is Avogadro's number. If you do not remember that, on your periodic table and equation sheets that you were given on the first day of school, Avogadro's number is right here on the very first page of your blue equation sheet. So if you ever forget it, it's right there. You can always look it back up. Also remember that on the periodic table, they have information about your molar mass. The bottom of the periodic table has your molar mass. That value tells you how many grams that element has per mole. So if we're looking at calcium, its number is 40.08. That means there are 40.08 grams of calcium in 1 mole of calcium. We do not round molar masses. We keep them exact numbers. You also have your periodic table. This is the accepted periodic table for AP Chemistry. So whatever values are on here, this is what you go with. These might be slightly different than the periodic table that you used in previous years of chemistry, but these are the values that we're going to go for right now. So on your packet again, there's some practice doing molar mass. I would hope that this is something that you remember how to do. This is something that might look different to you. You might need to look that up to figure out how to handle that. And then a couple questions asking you to convert between moles and atoms or molecules using Avogadro's number. Again, these are things that we did a lot in first year chemistry. If this is something you need some help with or a refresher on, please let me know and I will help you out. That wasn't too bad. That was a little long, but not super bad. Like I said, in general, I'm going to try and keep these as short as I possibly can. If you have other questions about anything, please let me know in class. I will see you next time. Bye.